Greetings to all my tech heads out there in the KevTechify nation. And if you're new here, welcome. In this episode, we're going to look at fiber optic cabling. We'll be discussing the properties of fiber optic cabling, the types of fiber media, single mode and multi-mode fiber optic cabling usage, fiber optic connectors, fiber optic patch cables, and then finally we'll have a discussion about fiber versus copper. In this episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. Now, the properties of fiber optic cables here is most people think of fiber, they think it's expensive. And it kind of is in today's world. You have the cable itself, which is more than copper. Just the cost in per foot. You have to look at installing it. Fiber is very forgiving and you can run it into a lot of places. Fiber is more delicate. You have to give it more care, and there's certain things you have to do to protect it when you install it. You have to put ends on it. Copper, twisted pair, I can put an end on. The end costs me 45 cents. I have the tools fairly cheaply. Putting an end on fiber is an expensive deal, and we'll talk about that here coming up in a little bit. Fiber optics we do use in some networks. Some networks are definitely geared more for it than others. We have fiber optics that go over longer distances. We're talking miles compared to a maximum of 300 feet when we're looking at that. Fiber optic isn't susceptible to EMI or RFI. They don't get interferences from that. They use a laser or an LED to make those light pulses that go through the fiber. And that fiber, with those light pulses, it acts as a waveguide. And so fiber optic, it can bend and the light pulses will follow through with that. Now, there's two types of fiber optic cable. One is single mode and the other one is multi-mode. Single mode, you have your piece of fiber and it's running towards you, and that pulse of light is shot straight in and it travels through there. It travels through there, it can go longer distances than multi-mode. Traditionally, you can go faster, it can have more data, but you only can send one signal through there. Multi-mode is a piece of fiber, and a lot of times it's a different fiber, and it has definitely different ends on it. And what we do, instead of shooting that signal straight in, is we send those light pulses in at an angle. Because that fiber is a parallel process, that light goes in there, and the angle you shoot it in is the angle it reflects at because they're parallel, and it keeps reflecting through there at that angle. Because they're parallel, it will come out on the other end at that angle. And so light shot in at one angle comes out at the same angle on the other end. Now, if you shoot one light in at one angle and another light in at a different angle, we can have sensors on the other end that detect the different angles of light or the different signals coming out at different angles, and you can get multiple signals across there. Now, multi-mode fiber doesn't go as far, so it's a limited distance, but you can get multiple signals over that. You traditionally don't get as fast as data transfer with multi-mode as you do single mode. Typically, single mode is faster. Where we use fiber optic cables is typically in enterprise networks. We normally see fiber optics being used in a data center when we have to transfer between our database and our enterprise resource planning packages and our web servers. When we have to send data, large amounts of data between devices in our data center, we normally go to fiber optics because we can get a much higher throughput there. Another place we see fiber is fiber to home. Some cities, they actually ran fiber to the home, and we're supposed to get a higher bandwidth. Even though I know some people that have fiber to their home, they say they don't get that great of a speed through it. But at least they have fiber to home. Hopefully they'll improve the technology that are connecting there, and they will get hopefully blazing speed sooner. I do know, I have talked to a couple of my friends. They do get 700 gig per second download once, and so that's pretty impressive to see that. Another place we use fiber is what we call long haul networks. This is the networks that connect up cities to cities. When you have one city and another city that's 100 miles away, that's a long haul network. We typically run fiber along roads, along freeways. And sometimes as you're traveling, you'll see these crews out there burying these cables. And they bury these cables underground. And they can go for 50 to 60 miles underground before they have to repeat that signal again. So these networks, the data can travel really long ways, high speeds, great quality through that. And another place we use fiber optics quite a bit is submarine cable networks, connecting continent to continent, North America to Europe. Our submarine cables there are fiber optics. Yes, because we can do the long hauls between them, or between between repeaters. We can do 50, 60 miles between them, where if we would use copper, it's only 300 feet. Big difference there. But think about running a pair of wires using electricity through water. It could short out, and that would be a bad thing. Where if fiber gets water in there, it's not going to necessarily short out. It's probably not good for it in the long run, but it will continue to work, and it won't blow up everything else in your network. And this is usually where we see fiber optics used in our networks. If you like this episode on fiber optic cabling and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, subscribe to my channel, leave a comment. Doing this supports the channel, which in turn helps me provide you with great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Now, the ends of fiber. I talked about using shielded twisted pair and unshielded twisted pair and having those ends on there, putting them on. I can do that. I have put fiber optic cables on, or ends on cables. I've done it twice. I don't think either time I got them to work. It is a long process to do that. What you have to do is you have to get your strand of fiber. You have to cut it off. You have to cut it off at perpendicular, at a perfect 90 degrees. Once you do that, and you can't crack it, you can't break it off, it has to be a cut, so it has to be flat. Then you have to polish it, and you have to polish it till it's a perfect mirror finish. And what I mean by perfect mirror is you look at it under a powerful microscope, and if you see one little scratch, you still have to polish it and polish it. And sometimes it takes 5, 10, 15 minutes. I spent like 20 minutes and I still never got it perfect. And then once you have that, you have to put the ends on. And here you see we have a couple different ends you have to put on there, and they're not easy to put on. Meanwhile, trying not to touch the end or anything like that. And if you, while you're putting on the end, you touch the end or you break the end, you have to start all over. So it's a very complicated process. They do make machines to put ends on fiber optic cables. And if you ever have to put an end on a cable, I would definitely get a machine. I would hire a professional in to put the ends on my cable. But the easier, better way to do it is just buy pre-made cables. Unless you're installing fiber optics under the ground and you're terminating them, you probably can always get away with buying pre-made cables. And they're going to be cheaper than your time, materials, your sanity to put in there. And you'll get it done right. Here, there's 4 different connector types. And as you can see, there's varying. And some of them are proprietary, some of them are open. There's certain ones for multi-mode, single mode, all these different types of connectors. These are the patch cables I talked about. Go out, buy the patch cables. Cheaper, it's going to save your sanity. It's a much better process for you. I will tell you one thing. There is an unofficial standard in fiber patch cables. If you look at the 2 orange cables, typically the orange, or it could be an aqua, a light blue, that is typically for multi-mode fibers, multi-mode cables. Yellow, The yellow jacket is typically for single mode. And notice I'm saying typically, I've seen where it hasn't been, but normally if you see orange, that's multi-mode. Yellow is single mode. Okay, let's compare fiber to copper for a second. Looking at this, copper cabling goes from 10 megs to a gig to even up to 10 gig. And maybe, yeah, for right now, realistically, it goes up to 10 gigs per second. Fiber will go as low as 10 megs per second, but it'll go as high as 100 gigs per second. So it's 10 times faster at its max. Distance is probably the big thing that fiber has over copper. Look at the distance. Unshielded twisted pair, that copper goes a maximum of 100 meters. 300 feet is all you can get out of that before you have to put a repeater in there, clean up the signal, and rebroadcast it again. Fiber, on the other hand, you can go 100,000 meters. That's over 60 miles you can go with fiber optics single mode. And that's why they bury it in long haul places. That's why they run it on the ocean floor to do that. Then it has immunity to interferences and electrical hazards. We look at the connector costs. For the copper connectors, it's relatively cheap. For fiber, it's relatively high. Installation skills, copper. You can have your interns typically install copper. Fiber, you probably want to hire professionals in. Safety precautions. Typically copper is low. Yes, you're dealing with electricity, but it's only 48 volts, so it may tickle a little, but it's not going to do any damage. Safety precautions for fiber optics. Yes, if you touch the fiber, it won't give you a shock or anything, but it's much more fragile, and you have to take safety in protecting that, and that's where we see that it's a higher safety factor for fiber optics. It was my pleasure to provide you with this wonderful episode on fiber optic cabling. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.